And there we go. Okay, so we're recording. Hi, I am Laura Fisher. I love math. I love doing this. I'm really glad y'all are here. Definitely don't have anywhere near the 165 people showing up now. I know a lot of people are going to watch it on video, and it is going to be recorded. Sorry, I'm going to try to cut back on my ahs. I'll feel a lot better when I'm back to doing the math and not just this part. So I want to go ahead. I want to respect your time. We're going to go ahead and get started. So I'm going to turn off my video camera because when I do this, I disconnect my tablet. I have a Microsoft Surface. Absolutely love it. And I disconnect the keyboard. And I'm wearing a headphone because it helps minimize the sounds that my computer makes as it's kind of moving around on my tabletop. So what you're going to want to do, if you haven't already, is have these notes out. And because we don't have as many people in here as I was initially expecting, I want you to feel free to unmute yourself if you would like to participate in more of a classroom style. In fact, I'd love it if people would just go ahead and kind of chime in with an example of a goal that we have to be deliberate about achieving. Does anybody want to be brave enough to unmute themselves and say something that they have to be deliberate about achieving?
Can you hear me?
Oh, yes, I can. Hello.
Hello, how are you?
I'm doing well. Are you going to participate here and tell me about a goal that you have to be deliberate about achieving?
Yes, I'm going to try. I think I know what you're trying to get at, but I'm a mom. I'm a mom of 8, homeschooling for going on 19 years.
God bless you.
Thank you. And I have a couple kids with dyslexia. One of them has an IEP. It's pretty severe. And for him to learn, he's going into 7th grade, but his math is not even close to 7th grade.
Right.
In terms of his age. And so he's going to be, doing a math program with other kids his age at like a enrichment place. And I'm trying so hard to get him to learn his multiplication tables, and it's so hard. I just don't, that's my goal, that because if he can't do the multiplication, he can't do division, and everything is just completely hard. He writes the numbers backwards when he does double-digit multiplication.
Oh,
and it's just such a struggle, poor kid. And so I added myself to this, hoping that I could get some strategies to help him. So that's kind of one of my really, really big goals, is if that's kind of what you were asking.
It is kind of, and I do, because I'm guessing that there's going to be a lot of parents who are running into the same thing. First of all, and this is one of the reasons, if you've been to my website, this is one of the reasons why I left traditional classroom teaching, is I just got so tired of the kids being crammed into that grade level mold based on their age. I had lots of students that were behind grade level, and I would have loved to just meet them where they were educationally and mathematically. And I couldn't. If they were in 8th grade, I was expected to teach 8th grade math, and I would do my best to try to bring them up in other regards. But it was really not realistic. And so I just wanted to say that if that is your child, the number one suggestion that I have is to always keep a multiplication table, which I've included in the freebies, and an addition table, and make sure they know how to use them so that they're not making the mistakes based on just those math facts. If they cannot memorize it in spite of everything that you're trying, please don't beat yourselves up on that. And then hopefully you will be able to get some things out of this. I was thinking, as far as this question, what are some examples of goals that we have to be deliberate about achieving? This is the one, and you'll laugh, I keep waiting for my extra pounds to just come off magically. And I think by now I've realized, yeah, that's really not going to happen. So does anybody want to go ahead and throw out another type of thing about goals? And for the mom who was just sharing, it is an excellent goal to want to help your kid. And that's really what we are here for. Does anybody want to suggest another, just for yourself as a human being, as a parent, a goal that you know you'd like to achieve, and maybe you're on that process? If you'd like to unmute and add, please do.
I've got one.
Yeah, go for it. Yep.
Yeah, so I have a daughter who is really just a beautiful pianist and has completely surpassed me in being able to play the piano. And that is something I struggle with, is fingering on the piano, because if I can't master that, I just can't ever advance in my ability to play piano.
Okay, so that was actually one of the ones that I was thinking of, is learning an instrument. And now, of course, you are already on that. And we're going to talk about just in a couple more points here where we let them turn the tables on you. So learning an instrument is an idea. Does anybody else want to throw out a goal?
I'll mention another one now that I kind of understand where you're going with this, that being organized.
I'm sorry. I'm laughing because I was trying to anticipate organize. I was thinking in terms of decluttering. Was yes. My thing. Yeah, so I'm going to go ahead and put decluttering. And then one that my husband and I are really passionate about helping people with is instead of calling it weight loss, we'll call it debt loss. My husband and I were able to become 100% debt free, and then we purchased our house. Yeah, so not so much, but we are working on aggressively paying that down. So, and we could probably go ahead and add a whole bunch more things on here. So as far as the kids learning their math facts, it's something that we have to be deliberate about, at least for some kids. I mean, there's always things that people can do very well, and it just seems to come naturally to them. Memorizing math facts was never an issue for me. Learning dance moves when I was in dance class as a kid definitely was something that did not come naturally to me. We all have those things. And so for us as parents, especially as homeschooling parents, is that we want to be our child's personal trainer. That's what's going on that line there. We want to be our kids' personal trainer. We kind of have to be watching them, just like a personal trainer would do at a gym. Like, oh, straighten out your back, or turn your toes, out a little more, or whatever it is a personal trainer would say to somebody when they are working out with weights, or perhaps like a sports trainer. Is we kind of have to be on the lookout, especially for stopping some bad habits. And I just want to say, as far as, I'm going to call counting on our fingers a bad habit. The example is that I see is kids will, okay, sorry, I'm going to double back. The example I like to use is my son, Dusty. He's my younger son, and it doesn't have anything to do with math. It has to do with walking. He took his first steps when he was 13 months old. He did not start walking for 3 months because for him, he found crawling to be faster and more efficient in keeping up with his older brother. And I find that when we teach kids how to count on their fingers, it works for that time, but some of the kids have a harder time of moving on to other strategies. And so it's kind of like my son Dusty, where he waited to walk. We kind of have to be a personal trainer for our kids to kind of get them past that that whole counting on the finger thing. And so one of your key things is that you're going to be redirecting them to a strategy, and we're going to be talking about those strategies. So redirecting them to a strategy is one of the things you'll be doing as their personal trainer, or redirecting them to the chart that I was just talking about, if nothing else, people who use a multiplication chart or an addition chart, that can be really quick and efficient. You just want to make sure that that's an accommodation that your kids are allowed to use if they're doing the state testing, which is a whole, just a whole nother ball of wax there that we can talk about. And then just a final thing is, when you're working with your child, is make a note. You know, if you see them struggling on a particular fact, make a note of it. Identify the fact that they're struggling with so that you can go back and work with that. This little topic here, let them turn the tables. This is something I always wanted to do when I was teaching in the traditional school, but I really did not have the time, was saying to some of my students, hey, you know, I'll work with you on this, and how about if you work with me on getting out there and moving? You know, get me to run some laps or something. So you can actually have them, give them permission to be your trainer. Hey, we're going to work on these multiplication facts or these addition facts with you, but I'm going to let you be my personal trainer. You're going to be the one who snaps the fingers and says, hey, all right, mom, we're going to do this drawer. Come on over here, start decluttering this drawer. Okay, what categories do you see what I'm saying here is let them be your personal trainer for something. And it can be very empowering to them. And then how to be stubborn. This is something kind of random. I'm just going to throw out there that when I was homeschooling my kids, and that was something I did want to mention, is that I homeschooled my kids, and I was doing it as a divorced mom, which was tough because I was teaching math and science out of my home at the time. And it would be very easy, and I'm guessing some of you have experienced this, is to just go, oh, whatever, just go, you know, go play, we'll finish this later. Oh, I see somebody's finishing an AA, and that is awesome as far as having a goal that you got to be deliberate about. Good for you. But what I would do is I used to do needlework. I don't do it much anymore, but I would do needlework. So I would bring my needlework to the table when they were working on their math. And I'd be like, you know what? As long as we have to sit here, I'm cool with that because I'm doing something I really enjoy. And so they knew, oh, mom's going to be really stubborn about this. So, fine, I'll just get this done. So for me, how to be stubborn was just doing needlework while they did math. So think of something that you can do that you'll enjoy so that you can be positive when they're perhaps being negative. All right, so let's talk about what they already know. So you'll notice that in the freebies, I included some assessments, 2 assessments, one for addition, one for multiplication. And have your child sit down, and you may want to just monitor them just so you can kind of make some notes and stuff. Don't time them on this, but do emphasize that you're trying to figure out what they already know automatically, which facts they can do, which ones they've already got memorized, so you can get a better sense of where they are. So if they don't know it within like 2 seconds, encourage them to skip it, just leave it blank, move on to the next one. And I do know some students I've watched when they take a facts test, they might go through looking for the ones that they know. Encourage them to just go through, find the ones that they know, the ones they don't, they can just skip it, but have them be methodical about it. And then for the times tables, you may have noticed if you've looked at it, is that I go all the way up to the 12s on this assessment. I didn't learn my 12s until I was like late high school, where I had them finally all nailed down. But the 12s have a lot, they show up a lot, particularly when you're talking about angles, which may sound a little bit weird, but angles are 360 degrees, and that number can be divided by 12. There's a lot of factors. In fact, there's 22 different factors that multiply together to make 360 degrees. So I think that learning the 12s is a valuable tool. So there are those assessments. Just monitor it while they take it. And then when they've done that, you want to go through and go, okay, so let's make a note of what you know how to do. You can use star stickers. If they're older kids, they might be insulted by star stickers. I don't know, but I've also worked with high school kids, at-risk high school kids, and it's surprising how often they're motivated by stickers. So you can go through and go, all right, well, you know your twos. And you can go through and you can put the stars on the ones that they know, and then you'll have a sense of what they don't know. And I would suggest print several of these charts, because you're going to see in a moment that there's the different strategies. In fact, let me just show you this. So if your child is overwhelmed looking at those 100 squares of facts that they would have to memorize, we cut it in half. 8 plus 9 is the same thing as 9 plus 8. So there's those duplicates. And you'll notice at the cutoff point, it leaves the doubles. So you've got the 1 and 1 is 2, 2 and 2 is 4, and so on. And so you can hand your kid a pair of stickers and let them just cut off that half of the chart, or you can let them just go at it with a black marker. I'm trying to erase my highlighting. There we go. That doesn't look quite as overwhelming, and it's very satisfying to remove half of the chart, because it makes you feel like, okay, that's not as much. And I just want to take a look at my notes here. I just want to make sure that I'm not leaving anything out. All right, let's look at these strategies, okay? So we're going to start with the addition strategies. And these are so incredibly helpful, some of them. In fact, some of them I didn't learn until I became a teacher. And it was just really surprising to me that some of these strategies, I couldn't imagine why these were never taught to me. So the first strategy is counting on. And this one, I would say only for +1 and +2. Okay, only for counting on by 1, counting on by 2. Any farther than that, then they just want to count for everything. So having the kids recognize that it's okay to count. So if they have, and let's say it's 2 plus 5, and they don't have it memorized, for the younger ones, you may need to teach them to start with the larger number. You say 5 and then count 6, 7 for the 2. Okay, that is an example of counting on. And on the chart, look at all of these facts here that are taken care of, if you will, just by that strategy of counting on. And they do eventually memorize it. They don't have to count, you know, barring any learning disabilities. It gets to the point where it's so fast that they basically have memorized the fact. All right, then we have the doubles, okay? The doubles are those, and you probably already know what I mean, the 1 plus 1, the 2 plus 2, and so on. And those are some of the first ones that kids learned, because just that one fewer digit just makes it a little bit easier for your brain to hold on to it. But they do have to be memorized for the most part. So here is a silly little strategy. We'll talk a little bit more about flashcards later on, but you can create flashcards, and actually the kids, you want to have the kids creating the flashcards as much as possible. You could make posters. There's all sorts of ways that we can do this, but I have these little images, and you could put these onto index cards. You can create some photographs, some more on that in a little bit. So 2 plus 2, I thought this was hilarious. These are identical twins who married identical twins. So 2 plus 2 is 4. Bugs, insects, have 6 legs, 3 on each side. So 3 and 3 is 6. You're very welcome that I put a cartoon spider and not the real thing. There were some very creepy spider pictures. 4 plus 4 is 8. And always love tying in science when I can. These are arachnids. Spiders are arachnids, so are scorpions. They have 8 legs and not 6. I think everybody, 5 and 5 is 10, is probably the first double that they learn. Eggs, 6 and 6 is 12, and then of course you can talk about the word dozen. Gets a little harder when you get up to the bigger doubles. 7 and 7 is 14. So 2 weeks is 14 days. You could introduce the word fortnight, which is an old British term for 2 weeks. And then I kind of stretched a little, like, okay, how could we do 8 and 8? Well, we could do 2 octopuses, octopi. 8 and 8 is 16. And then I was like, okay, what could we do for 9 and 9? Oh, well, baseball teams have 9 players, but not all 9 players are on the field at the same time, or are all 18 players. Like, oh, yeah, except when the bench is clear for a fight. So 9 plus 9 is 18, and then, of course, fingers and toes, 10 plus 10 is 20. So getting those doubles, if you're having to work on memorizing with your kids, doubles is the best place to start. I just want to take a quick moment to pause. Are there any questions? Don't worry if you are, you feel like you missed something. Just remember that this is all recorded. All right, let's see. Almost doubles. So going back to those strategies, we have the almost doubles. And this is, once the kids have the doubles memorized, this would be the next step that you want to move to. The almost doubles, and they need to be able to recognize these. And with the game that I included, there are cards with the different math facts. You could call them flashcards. I don't anticipate you using them as flashcards. You'll see why later, but you want them to be able to recognize. So maybe go through those cards and pull out the ones where they could go, oh, that's an almost double. 5 plus 6 is the same thing as 5 plus 5 plus 1 more. So if they know that 5 plus 5 is 10, 1 more would be 11. So there's this, with this strategy, we're building. You probably already picked up on that, is that we're building on each other. And so we want to go in this order that I'm kind of suggesting here. And when we look at the table, go back to those tables. So this one is the doubles. Okay, so highlighted in purple here, you can see that the chart, we're attacking that bottom triangle. We're attacking this big section here of all these facts to memorize. So you've got the counting on, where you just have to add a 1 or a 2. Then you have the doubles. So even more of the chart is attacked. Then you have the almost doubles, where it's a double plus 1 more. So more of the chart is getting used up. And then we have the making 10s. You can think of these as 10 partners, okay? The 10 partners. And these are a really, really good thing to get the kids to nail down and memorize. Again, this one is a memorization thing. So I was really having some fun with this. We go together like, and I don't know if you guys remember the song from Greece. We go together like Rama Lama Lama, Kadinky Dinky, whatever. I don't know. I'm certainly not going to sing it for you. But we go together like macaroni and cheese. We go together like milk and cookies. We go together like peanut butter and jelly or bacon and eggs. We want to communicate for the 10 partners that these are special partners of numbers. We go together like peanut butter and jelly. So this is something where you can really start having fun with your kids. And I'm going to reiterate that you want to have your children put these things together. So you can see here that 8 plus 2 is 10. And so I decided, okay, this is going to be my peanut butter and jelly fact. So as you can see, I just got some Post-it notes. I did 8 for the peanut butter, 2 for the jam. You would have your kid, after they set this up, take a photograph of it, and then take a photograph of it with the answer as well. And then those pictures can be your flashcards, where you have the fact on the one side, and you could just write the answer on the other. But it's amazing how much just making the flashcard itself will help kids. Then, to reinforce it, you take the time right after he makes this little setup, you make peanut butter and jelly on toast. And you could even do it, if you can't tell, that's a picture of embossed toast. Crazy the things we can buy now in America, right? You can actually buy these stamps to stamp your bread before you put it into the toaster. But you can actually have number cookie cutters where you don't want to cut all the way through the bread, but you could use a 2 and an 8 and emboss those 2 slices of bread before you put them in the toaster, just to help reinforce that math fact. And we'll talk about the kind of the brain science that's behind it in just a little bit. But these are the things that are going to make each fact more memorable, and you want to have each one be different. And again, we'll talk a little bit more about that when we get to the bit about flashcards. Okay, so the Make 10 partners, if you haven't already on your notes, these are the things like 7 plus 3, 8 plus 2, 5 plus 5. Notice that that's a duplicate. That makes 10, but it's also a double. So there's going to be quite a bit of overlap. 6 plus 4, 9 plus 1. I think I hit them all. 1, 2, 3, 4, 5. Yes, okay. Then we have, when you have a number and you add 10, let's take a look at this. For the younger kids, when your kids are first learning their math facts, it may be helpful to them to actually have them count it out. So let's say that we were going to do 10 plus 7. For a younger child, you would say, okay, so here's 7, let's add 10. And I want to point out, I want everybody really tuned in here for a second. I want to point out that a lot of kids, here's a mistake that they make. They want to say 1 on the square that they start at. And that's going to throw things off. You want to teach kids that when you're counting, because this is something on a number line, and it's also something that I see on those coordinate graphs when they're counting like the squares, is they want to count the initial 1, but that's kind of your starting point. You start counting here on the 8. So we count to 10. 1, 2, 3, 4, 5, 6. I'm going to get, well, let me just do it here. I will send you the correct hundreds chart. I don't know if anybody noticed this. I left off the digit 1 on that. Okay, so let me go back to this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Aha. Especially for a young kid, they're going to recognize, wait a minute, I just go down one. Gee, honey, does that work for everything? What if you started at 23? Let's use a different color. What if you started at 23? Try counting to 10 from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it does work. So they start, when they see that, it's a powerful moment at a young age. Older kids may need to see that. I don't know. But it was always interesting to me to encounter a student who hadn't seen that, hadn't put 2 and 2 together, so to speak. So I wanted to bring that up, especially for the younger ones. And then I also want to point out, again, I used to work with some at-risk teens in an independent study program. So I always had to be really careful that some of these things that I would use with them weren't too juvenile. It would be very insulting to them. It would shut them down. So I created a second 100 chart with a bunch of words that have the word scent, C-E-N-T, on it, so that it just made it look a little bit, you could say, come on, this is not a baby thing. You don't have the word centigrade on, a little elementary thing, but you can, of course. So I just wanted to point that out. So that is the N plus 10. It's just really good if they can see it on a chart, and that's all that is some number plus 10. You're just putting a 1 in front of that number, N. What's really nice about using that 100 chart is when you go to do it for plus 9, it makes it really, it just makes it quick and easy when students realize, oh, if I'm going to do 9 plus 7, so let's look at it here. If I'm going to do 9 plus 7, if I start at 7, I drop down, that's like the 10, and then I go backwards 1. So this is the final answer right here. 9 plus 7 is 16. And that's just a really handy strategy for those adding 9s. And I love the fact that it's visual. That to me was just kind of eye-opening because I'm very much a visual learner. And I think that was one of the things, who knows, maybe somebody showed me that as a kid and it just made sense and I just kind of ran with it. I don't remember. Okay, so that's the 10 forward and 1 back. And I just want to check that I'm not getting a text message from anybody on my phone. And let me stop here. Okay. So let's go back and just look. So there's making 10 partners. Then you have the ones where you have 10 plus a number. Then we have something called decomposing. And this is something that combines with the making 10 partners. And what I'm going to do is I'm just going to show you a quick, let me make sure it's going to load here. There we go. This is just a PowerPoint slide that I put together because the best way to see decomposing is with visuals. And again, for the smaller kids, this is something that you would probably want to do with some sort of tokens. You could use pennies. You could use M&Ms, which is what I've got here, okay? 8 plus 5. So let's take a look at this. We've got 8 and we've got 5. And the idea of decomposing is breaking down the smaller number, which in this case is the 5. So what we're looking at is the 8 goes onto the 10 frame, and that's what that's called. It's a 10 frame. I made a nice big one for you. Then we decompose the 5 into 3 plus 2, and you can see, and I'll run it backwards here, okay? We're going to take these 2 and we're going to bring them over to the 10 frame. And here you should be able to see how it ties into that n plus 10. So now we have 10 plus 3, which is 13. So this is, I think, pretty obviously a much more complex strategy, but it's why it's the last strategy. I'll leave it up to you as parents, and if you have questions about it, you can always, please feel free to text me, to email me. I gave everybody my phone number in that email. The older kids eventually should be able to do this completely mentally, but again, if there's learning struggles, it's perfectly fine to let them do it with manipulatives. And I may even put together a workshop on using PowerPoint for this sort of thing so that kids can really dive in and work with PowerPoint, but create their own visuals that will help them in math. So if that's something that's of interest to you, please email me so that I know that that's something maybe I should spend some time on. Okay, so that's decomposing. Oops. And I don't know why that just went back to that. So let me close that. There we go. Wow. So look at this. This is our addition chart. Remember, we blacked out half of the chart because of the commutative property. That half of the chart is just a duplicate of the other half. And you can see all the different strategies on here covers everything except two facts. 5 plus 3 equals 8 and 6 plus 3 equals 9. I know some people with the plus 3, they'll do the counting on strategy, 5, 6, 7, 8. To me, because I try so hard to get kids away from counting, that's why I don't include this. But the fact that these stand out, I call these the oddballs, and you'll see it on the game in just a minute. Okay, I call those the oddballs, and just the fact that they're oddballs makes them stand out, makes them a little bit more memorable when it comes to the memorizing stuff. So let's go ahead and just look at the game really quick. I really had fun putting this together. This was a total brainstorm. And here's my suggestion is you get those cards, and first of all, print them on cardstock. You'll definitely want to print them on cardstock so that they're a little bit easier to shuffle. They won't get quite so mangled. I'm actually looking into having playing cards, like actually real cards printed, because I do think this could end up being a lot of fun. So what you want to do is you want to get all of those cards, and before you try playing the game, make sure your kids understand which fact, which strategy is related to that fact. So let's take a look. If we look at, and do I have a double on here? Yes, I do. Okay, so 4 plus 4 is a double. And you might want to do is just have some piles where they can separate the cards into the piles to kind of check to see, do they understand the strategy? So this one is a double, 4 plus 4. Then we could use a separate color and do an almost, let's look for some almost doubles. Aha, here's one. 3 plus 3 is 6, so 3 plus 4 is 7. That's an almost double. Let's see, do we have, oh, here's an almost double. And, okay, so let's switch colors. And hopefully you're looking at this and you're going, okay. How about the making 10, the 10 partners? Here's a 10 partner. And here's a 10 partner. And are there any other 10 partners on here? You can shout it out. You can unmute yourself if you want. Okay. Now, what you're going to find too is that there are certain strategies that overlap a little bit. I had already mentioned that 5 plus 5 is a double, but it's also a 10 partner. And that's part of what makes this bingo strategy bingo game. It truly is strategy on two senses. It's the strategies that we're learning with the facts, but it's also you can be strategic. So if you look, and there's 5 different bingo charts, there's lots of duplicates on here. Like if you look at this one, it's got those almost doubles all in a row. But because some of these facts fall in more than one category, you can be strategic with your bingo playing. So I think the rules on the bingo game are pretty clear. And if there's any confusion on it, please feel free to let me know, because I would like to refine the rules if that's necessary. Unless somebody like chats to me really quick or unmutes and says, I've got a question about this, I'll probably go ahead and move on. Okay. And how are we doing on time here? 10:41. Okay, we're not doing too badly here, I don't think. All right, so let's move on in our notes here to this strategy for ditching subtraction. This is where I really see a lot of kids counting on their fingers. Counting on your fingers works, absolutely. It's just not the most efficient way of doing things, and so we're just putting tools in the kids' tool belt. And I recommend that if you have a child who's counting on their fingers, especially for subtraction, and I'm thinking like right now, I'm thinking of long division, where kids are having to do subtraction on long division, and it just makes the process that much more frustrating if they're like having to count on their fingers for all of the subtraction steps. So I've got 2 examples here. I've got the first one here in blue, 15 minus 8. What I'm going to show you here is a strategy I call adding up. And the steps are here. You start at the subtrahend, which is that smaller number. Let me get a better blue here. Okay, so we start at the 8. Okay, and we jump to the 10. When we look at that, we can see that that's 2 units, 2 spaces on the number line. And then we jump to the minuend, which is that larger number. So we're going to be going to, this is 15 minus 8. You'll notice I did it from right to left. It's easier for me to see it that way. And I know that from 10 to 15, that's 5. Now I just add those jumps together and I get 7. Like anything else that we learn, this strategy can feel cumbersome. Such a great word. It can feel cumbersome. It can feel clumsy. It can feel like, oh my gosh, I can count on my fingers way faster than that. Initially, probably so. But this strategy becomes something that can be done very quickly mentally, but it does also require that your kids know the making 10 partners. So if you can look here, we jumped from the 8 to the 10. It will really help if your child knows that 8 plus 2 is 10. So this strategy kind of relies on some of the strategies that we just looked at, but it becomes super, super efficient. I use it all the time. Let's look at another example. And if you want, you can go ahead and start doing it on your own. Do the 13 minus 7. I'll get my purple pen here. And I'm actually going to give you a head start. This is what I do in my math classes. When I show students something, I'll say, okay, if you want to get a head start, I'll give you a head start before I start doing it, and then you can see how you did. Okay, that should be enough of a head start. Did you start at the 7 and jump to the 10 and think to yourself, that's 3. And now I'm going to jump to the 13, which is another 3. And the answer is 6. And I've got this in both my 6th grade and my 7th grade curriculum because I just feel like it's that important for kids to learn this strategy. And I would just suggest keep number lines out. And that's another thing that I put into your freebies is that have the number lines out. And I've got, it's a whole page of them. And kids will even get to the point where they can do it almost entirely in their head. So let's say that we're working with that 13 minus 7. They can actually go, okay, 3 and 3. They don't even have to do it on a number line, and they'll have it kind of figured out. And I just have a suggestion from somebody. I taught my youngest child touch math to help with kicking the finger habit. I have heard of that. It's only mildly on my radar. Because I've taught middle school for so long, I'm not very aware, but I will definitely look closer at touch math. And if that works with your youngest child, I'd say great. And then if nothing else, it's just throwing another tool in the tool belt that you can use as parents. So yeah, I'm going to explore that. Definitely going to explore that. Okay, so let's see. Times tables. Oh my gosh. Let's look at times tables. Alrighty. So much more memorization, not as much strategy. A big part of learning timetables is pattern recognition. The 2s, you've probably already filled in this blank. Oh, let me kind of fix that there. There we go. The 2s times tables are the same thing as the doubles. And typically kids don't have a problem with memorizing the 2s times tables. It's good to point out that the final digit is always even. Even and odd comes up, a fair amount. There's some different strategies, different math hacks that depends on knowing the difference between even and odd. I put for the 3s here, thank you Schoolhouse Rock. It is amazing to me. I am old enough, and you may have noticed I have white hair. That's because I teach middle school. I am old enough, I actually watched Schoolhouse Rock on Saturday mornings as like part of the commercials. I did not have to rent the videos to see Schoolhouse Rock for the first time. I watched them on TV in the 70s. And I still remembered. I just went back and looked at it because I was just so amazed at how much of the song for the 3s I remembered. And I realized, and I'm just looking to see, somebody else, somebody else watched Schoolhouse Rock. And I want to say it was on ABC. And that was back at Saturday morning cartoons. Good heavens, all you youngins out there who are watching right now. I'm feeling very old. Okay, so what you have is on the Schoolhouse Rock video, you've got these football players and their numbers on their jerseys as they're running out into the stadium. And it's 3, 6, 9, 12, 15, 18, 21, 24, 27. And there's like a brief pause and then a really big football player runs out with the 30 on the jersey. And I would go ahead and add times 11 and times 12 because I do encourage kids to be able to learn up to the 12s. I'm going to ask, does anybody notice anything? Don't worry about this part of it, but does anybody notice anything in the pattern here? And go ahead and unmute yourself if you want to comment on the pattern. And if you don't see it, I'm gonna put it on there in just a second. Well, doesn't look like we have. Oh, yay! There we go.
Well, in the the 9 square, you're adding 9 across each one of those.
Oh, for heaven's sakes. I did not see that. Okay, so what she just said, if you didn't catch it, was plus 9 is 12, 12 plus 9 is 21. I did not notice that. That is actually, and this is one of the things that's so cool about patterns, is there are so many amazing patterns in math. Okay, does anybody notice a different pattern, or if you wanted to continue with another observation? Oops, and I just realized I accidentally. Yeah, go ahead.
The numbers add up. So like in the threes column, the next column 1 plus 2 equals 3, and then the third column 2 plus 1 equals 3. At least in that section. So for 9, it'd be like 9 plus 9 equals 18. Well, I guess it doesn't. Well, yeah, 9, 1 and 8 equals 9, and 2 and 7 equals 9.
Oh, good grief. Again, this is something I had not noticed. And mine seems so basic and ridiculous now, the pattern I noticed. But let me point out what she's saying here. 1 plus 2, if you add those digits, 1 plus 2 is 3. If you add these digits, 1 plus 2 is 3. And then, and I could see somebody just chatted something to me. Look at this. 1 plus 5 is 6. 2 plus 4. Good grief. Okay, and these are multiples of 3. So the person who just chatted, yes, they are multiples of 3. Let me show you the pattern that I saw. Oops, I guess I'll just have to get that. There we go. Let me show you the pattern that caught my eye. Is this. These are all single digit. These are all teens, as in the first digit is the 1, and these are all in the 20s. Now, maybe that doesn't stand out to you as being particularly exciting, but this visual, and the more you explore it, like we just did, those observations that some of you guys made is blowing my mind. I'm used to some of that. We'll look at the 9s in the moment. The 9s also have tons and tons and tons of crazy patterns. But you don't see this with the other digits, the other times tables, where it's single digit. All of the factors here are in the teens. These are all in the 20s. So you can really have fun with this, with kids, in seeing the different patterns. And it just gives their brain more different ways of looking at these numbers. And it just, I don't know. I love patterns. I guess that's why I am the math dork that I am. The 4, and yeah, I did. I put a double. I live in Idaho now. I just moved to Idaho back in December, and I'm coming back in August to visit family and to do some charter school stuff. And I cannot wait to sink my teeth into a double. The 4s, the 4 times tables, I show my kids, and I just noticed the chat, the 3 song, and they love it. I love it too. Oh my gosh, happy memories. Okay, so double 2 is 4, double 3 is 6, double 4 is 8, okay, and it goes on. And I just heard somebody unmute. If you want to make a comment, please feel free. We don't have as many live participants as I expected, so it's all good. So the 4s are, hang on, I'm trying to get my picture as the background. There we go. The 4 times tables are doubles. So you double the 2, and then you double that, and you get 8. 2 times 4 is 8. 3 times 4 is double. 4 times 4, you double the 4 and then double the 8. Double the 5 and then double the 10. Okay? You can have your kids do this, and you can mix up these numbers so that, because here's what happens with kids, God bless them, they're so cute. they recognize the pattern. So they're not even thinking what double 3 is. They're just, oh, we're counting by 2s, 4, 6, 8, 10, 12, and so on. So they'll just start filling in the pattern, and that's okay. And then I wanted to point out that what to do with 18 and 16 and teaching kids doubling when regrouping is involved. So if you're going to double 16, and the thing about mental math is it's almost always done from left to right. When we do it on paper, we work from the right to the left because of all the regrouping. And when we do this mentally, so what we do is we think of 16 as a 10 and a 6. When you double the 10, you get 20. When you double the 6, you get 12. And it's a lot easier than trying to do that regrouping or carrying in your head that we do on paper. I think that's one of the biggest hangups for kids is when they try to do mental math, they try to do it the same way that they do it on paper. And that is really challenging. You want to teach them these different strategies for adding. And then, so let's look at it with doubling 18. 18 is 10 and 8. So if we double the 10, we get 20, and we double the 8, we get 16. Put them together, you get 36. The 8s are doubles, and really there's no benefit to it. And we're going to talk about how the 6s, 7s, and 8s are some of the more challenging math facts for kids. They really, it's just straight up memorizing. But there is a strategy for 5. And here's my thing about skip counting. Skip counting is great, except, let me just tell you a quick story about working with my grandson. My grandson came to visit, and I was helping him with long division. And he had been taught skip counting, and I believe he was doing 8. So he started writing 8, 16, 24, 32, and he was doing this for almost every problem, where if he had to do, and let's just say, I don't know, it was 8 into 65, let's just make up a problem here. So he would actually start doing this. And I think this is where Common Core goes completely off the rails. 56 and 64. Okay, so he would do this. He'd be like, okay, 8 goes into 65. He'd start writing these, and then he'd have to go through and count. 1, 2, 3, 4, 5, 6, 7. Oh, 8. Okay. And so this is where I kind of take issue with the skip counting. If you're going to do this, just break out the times tables chart. And when I taught long division, my very first year of teaching, I taught 4th grade. I would encourage the kids to have the times tables chart out so that they weren't slowed down by lack of knowledge of the math facts. Okay, so all of that to say, the 5s. Everybody can count by 5. It's a great pattern, 5, 10, 15, 20, and so on. But what I would see the kids doing is counting on their fingers. So they touch their thumb and they'd say 5, and then they'd say 10, 15, 20, 25, 30, and then they go, oh, 30 is 5 times 6. So they're looking at their fingers. And I think you guys probably know what I'm talking about. So to help your kids get beyond that, blue, the word blue has an even number of letters. So what you can do is have them go through, and it's always the ones that end in 0. Okay, this one is 2 times 5. This one is 4 times 5. The even numbered factors give you a product that ends in 0. So, and I put this one in the freebies as well. It's just the 5 times tables. You can have them go through and say, okay, look for the ones that have the even factors with the 5. Like this is 4 times 5. And have them try to remember, okay, 8, that one's 40. So you can have them go through and do just the even numbered ones, the ones with the even factors, 2, 4, 6, 8, with a blue pen or a blue colored pencil. Red has an odd number of letters, so we can use red and we can see 1 times 5, 3 times 5, 5 times 5. We just want to get the kids interacting with these numbers in a variety of ways so that it all stands out. And then we have the 9s. Wow, the 9s, so many patterns. I'm sure you've probably seen a lot of these. If you go down in the 10s digits, it counts up. And if you go down the 1s digits, or you can work your way back up, but we could go down 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That's a really cool thing. Then if you add the digits, oops, let me get a pen here. 0 plus 9 is 9, 8 plus 1 is 9, 2 plus 7 is 9, and so on. So there's a lot of really crazy stuff that goes on with the 9 times tables. You also have the finger strategy. If you don't know what the finger strategy is for 9, you can look it up. I want to be mindful of your time. It's fairly simple. But I want to show you a strategy for the 9s that requires less counting on the fingers or using your fingers. And let me just jump to 9 times 7 here, okay? What you do is you take that digit, the 7, you go backwards 1. That's your first digit in the answer. And because we know that the digits are going to add up to 9, 6 plus 3 is 9. So the answer is 63. Let's do the 4. 9 times 4. If your child can't remember it, prompt them what's backwards 1 from 4. 3. Hopefully that's enough to kind of nudge them over the edge, but at first you might have to say, okay, now 3 plus what equals 9? 6. We'll do one more. Backwards 1 from 8 is 7, and it's 7 plus 2 is 9. So those are the ones where we have at least some sort of strategy. The 6s, the 7s, the 8s, these are the ones that tend to be tougher. And this is where flashcards are going to come in. So we're going to take some time here to discuss flashcards. And you can actually have a ton of fun with this, as you'll see in a moment. So the problem that I see with flashcards is that they all look the same. There is nothing about these flashcards that stands out. And they just all run together in our brains. They're just so not helpful, in my opinion, unless you're doing strategies, you're doing different kinds of thinkings, like with the addition facts. So when I send you guys the link for the recording, I will also send you a link to an article called The Art and Science of Remembering. And it talks about memory palaces. I don't know if you've ever heard of memory palaces, but one of the things that came up in this article was, as bad as we are, and this is a quote from the article, as bad as we are at remembering names and phone numbers and word-for-word instructions, we have really exceptional visual and spatial memories. The crazier, weirder, more bizarre, funnier, Okay, raunchier, maybe we won't go there. Stinkier the image is, the more unforgettable and it's likely to be. So your goal is to have your kids creating flashcards that are going to be weird and funny and bizarre and not raunchy. Okay, so that these things are really going to stick with them. So you want to engage their brains. You want them to use as many senses as possible. That includes saying the fact out loud, and please make a note of this. Saying it aloud. Okay, so if you ask them what 5 times 6 is, you don't want them to just say 30. You want them to say 5 times 6 is 30. That saying it, that hearing it, is going to engage more of their senses than just saying the number 30. And we're getting pretty close to the end here. I want to thank you all for hanging in there. We're just about at an hour. Just a real quick PowerPoint here. And again, I'm really considering putting together a video for this. You can, and there's lots of videos for PowerPoint. If you don't know how to use PowerPoint, you can certainly learn from the videos, but I think I will do one. It keeps kind of tugging at my heart to do this, is creating digital flashcards using PowerPoint. So your kids can come up with the fun backgrounds, and then they can have animations. Let's see if we, there we go, for the answer. And they can make them as different and as unique as possible for each math fact so that it's more memorable. And let me get my, because there was an animation here, let me see. Okay, that 36 was supposed to kind of roll in and it didn't do that, so, oh well. Okay, so digital flashcards using PowerPoint. And then again, just kind of ridiculous, but kind of fun too. I'm going to reiterate it again. Have your child make the flashcards. That process of writing things down, creating, is going to be what's going to help get the information in their head. I mentioned that I used to do some needlework. There's plastic canvas. Your kid can actually embroider a flashcard. Okay, and again, keep just one unique idea per fact. Don't embroider an entire set of flashcards for the 7 times tables, just do one fact. You can use glitter glue or puff paint to create a memorable flashcard. Mr. Sketch Pens, talk about going down memory lane. Mr. Sketch Pens, I was probably the only kid in my school that liked the black licorice smell, and the cinnamon smell still just makes me want to die. I love it so much. So kids could do a flashcard with Mr. Sketch Pens. They could even learn some calligraphy and make a flashcard with just a few facts with calligraphy. This is something I just pulled out a styrofoam plate and did 6 times 8, and then on the back scratched in the 48. Okay, again, so that you have kind of a nice little set, you can take photographs of these things, and then you'd have a nice, you know, same size kind of set of flashcards for your kids. And then again, just a little reminder, kids make the flashcards. And then I have a category that I'm calling anti-flashcards. I would say combine this idea with maybe another project where you use plaster of Paris in sand. There's all kinds of different crafty things that you can do with this, and you can do it with the times tables. The interesting thing about this is the kids would have to imprint into the sand mirror images. So if they were going to do 7 times 3 is 21, and if they wanted to put it all in the same thing, they'd have to figure out, and you can hear my brain trying to figure this out. There we go. And then pour the plaster in, and it comes out the right way. This is such a fun idea. Give them a paint roller. They can go and roll it into the pavement with water, take a picture of it. There's the cookie cutter idea. Again, you'd probably want to save just the one math fact for the cookie cutter. If you haven't seen Post-it note art, oh my gosh, what fun. Can you imagine working in an office building and having this on the office building across from you that is all made with Post-it notes? So what I did was I was going to do 6 times 8 on my window, but I didn't have enough time. But getting that figured out was actually, there was some interesting math in there because I was kind of mapping it out on grid paper. And I know that Minecraft is exceedingly popular with a lot of kids. And so you have pixelated images. There's a lot of math involved with that, and that's actually pretty cool. And I'll try to remember to include this link, Post-it. If you just go to postit.com, it actually has an article on creating sticky note pixel art. Here is a fun idea. This is kind of taking off from something that a colleague of mine had. I don't remember his exact reference, but I combined it with a little Sunday school thing of Goliath. But butcher paper, you could use parchment paper, but draw a stick figure or a person who is 6 feet 7 inches tall and put a jersey on them with the number 42 for 6 times 7 equals 42. They'll probably never forget that one if they have a chance to do a 6'7" stick man. There is also 5, 6, 7, 8 for 7 times 8 equals 56. And where is it? And there we go. And then just this last one, this is crazy. I've seen cups in chain link fences. This is little bottles of water dyed with food coloring. You could make water bottle art. Of course, these are all, some of these are really over the top, but you know, we're homeschoolers, for heaven's sakes. Let's do some of this fun stuff to help our kids learn their facts. And then finally, I put together another game, and this one is for the multiplication and division facts. As your child becomes more fluent with their times tables, they should, in theory, become more fluent with the division part and working with fact families. And for example, 4, 3, and 12 is a fact family because of the associated number sentences. 3 times 4 is 12, 4 times 3 is 12, 12 divided by 3 is 4, and so on. Okay, that's fact family. And so this is another game where the kids are really engaged with the times tables and strategizing. And I think, again, I tried to think of every possible thing for the rules and explaining the game. As you go through with the game, if you find yourself confused by something, please let me know so I can clarify it. Let's see, I'm just checking my text messages to make sure I've gotten anybody's. Okay. Wow. So I am going to go ahead and stop the recording.